Question here is NC4 is equal to NC6. You need to find N. Okay. From the formula for NCR, NC4 is factorial N by factorial N minus 4 into factorial 4. And NC6 from the formula is factorial N by factorial N minus 6 into factorial 6. You take everything on one side, factorial N by N minus 4 factorial into 4 factorial minus factorial N by N minus 6 factorial into 6 factorial must be equal to 0. Now what you do here is factorial N by factorial N minus 4 you write as it is. Factorial N minus 4, what you can write? You can write factorial N minus 4 as N minus 4 into N minus 4 minus 1 into N minus 4 minus 2 factorial, right? And factorial 4 you write as it is, minus factorial N by factorial N minus 6 you write here, and factorial 6 can be written as 6 into 5 into factorial 4 is equal to 0. So now you get factorial N by N minus 4 into N minus 5 into N minus 6 factorial into 4 factorial minus factorial N by factorial N minus 6 into 6 into 5 into factorial 4. Now you see from these two, you can take factorial N by factorial N minus 6 into factorial 4 common. So what are you left with? You are left with 1 by N minus 4 into N minus 5 minus, and here you are left with 1 by 6 into 5 is equal to 0, right? So that means this part here is 1 by N minus 4 into N minus 5 minus 1 by 6 into 5 must be equal to 0. Now what you do is you multiply. You get n square minus 9n minus 10 minus 1 by 30 is equal to 0. Okay. So now you can take the LCM. 30 times n square minus 9n minus 10, and in the numerator you will have 30 minus n square minus 9n minus 10 is equal to 0. So that means 30 minus n square minus 9n minus 10 is equal to 0. That means you get 30 minus n square plus 9n plus 10 is equal to 0. Okay, so you're getting here 40 minus n square plus 9n is equal to 0. Okay. So that now if I take minus out, you get n square minus 9n minus 40 is equal to 0. N square minus 9n minus 40 is equal to 0. Okay, now can this be factorized? When you are multiplying, this should be plus 20, not minus 10. Okay, so you get LCM will now become plus 20. So you have 30 minus n square minus 9n plus 20. Okay, now change accordingly. This should become minus 20. So you get 30 minus 20, you're getting 10 here. 10 minus n square plus 9n. So that now if you take minus out, you get n square minus 9n plus 10. Now I think this can be factorized. Okay, this can be factorized into two factors, 10 and 1. So minus 10n plus n. Okay. Still we are not getting. This should be a minus 10 here. Because when we are opening brackets, yes, when we are taking minus out, this should be minus 10. Now this is okay. N square minus 10n, this is minus 10 equal to 0. So you're getting n into n minus 10 plus 1 into n minus 10 is equal to 0. That means n plus 1 into n minus 10 is equal to 0. That means either n is equal to minus 1, which is not possible because n is a natural number, or n is equal to 10. Hence the value of n that we solve for is 10. Okay, we'll move on to the next sum. Number 3. Given here is NCR is to NCR plus 1 is equal to 1 is to 2. Okay, and another condition is given. So what we'll do is we'll first work out this. NCR is to NCR plus 1. In fact, what will happen is that if you put the formula here, put from the formula, you'll get one equation from here, and you will get one equation from here. You'll get simultaneous equation which you can solve to get the values of n and r. Okay, so let us take the first one. So you have NCR by n is to NCR plus 1. So you have NCR by NCR plus 1 is equal to half. Okay, now you put the values here. Factorial n by factorial r into n minus r factorial divided by factorial n divided by r plus 1 factorial into n minus r plus 1 factorial is equal to half. Okay, so this now see that factorial n and factorial n are going to cancel. So what in the numerator, what are you going to get is r plus 1 factorial. And if you open the within the curly brackets, if you open, you will get n minus r minus 1 factorial divided by factorial r into n minus r factorial is 1 by 2. Now you see that you have r plus 1 factorial in the numerator and you have factorial r in the denominator. So you can write r plus 1 factorial as r plus 1 into r plus 1 minus 1 factorial. You can write this way. And you write n minus r minus 1 factorial as it is. In the denominator, you have factorial r and you have factorial n minus r, which can also be written as n minus r into n minus r minus 1 factorial is equal to half. That means you are getting r plus 1 into factorial r into n minus r minus 1 factorial divided by factorial r into n minus r into n minus r minus 1 factorial is equal to half. So what you get here is this factorial r and this factorial r will cancel. This n minus 1 minus n minus r minus 1 factorial and this n minus r minus 1 factorial are going to cancel. So ultimately get here r plus 1 by n minus r is equal to half. Now you cross multiply, you'll get 2r plus 2 is equal to n minus r. You're getting a simultaneous equation in n and r. Okay, so you get 2r plus r minus n is equal to minus 2. I can write plus 2 is equal to 0 also, no problem. You take everything on one side and therefore you are getting 3r minus n plus 2 is equal to 0. This is your equation number 1. Okay. Now if you see the second condition is also given here. Second condition is NCR plus 1 NCR plus 1 is to NCR plus 2 is equal to 2 is to 3. This again, if you simplify, put the formula and simplify, we are going to get another equation in n and r. So you get NCR plus 1 by NCR plus 2 is equal to 2 by 3. From formula you have factorial n by factorial r plus 1 into n minus r plus 1 factorial divided by factorial n divided by factorial r plus 2 into n minus r plus 2 factorial is equal to 2 by 3. So first of all, factorial n and factorial n are going to cancel. What you are going to get here is r plus 2 factorial. If you open the bracket here, you get n minus r minus 2 factorial divided by r plus 1 factorial into n minus r minus 1 factorial is equal to 2 by 3. Now we need to simplify this to get another equation. Now if you see here, you have r plus 2 in the numerator, right? That means this can be further be written as r plus 2 into r plus 2 minus 1 factorial. And you write n minus r minus 2 factorial as it is. In the denominator, you write r plus 1 factorial as it is. And you have got n minus r minus 1 factorial, which can now be written as n minus r minus 1 into n minus r minus 2 factorial. Or let's say minus 1 minus 1. N minus r minus 1 factorial is equal to 2 by 3. So therefore you are getting r plus 2 and this is r plus 1 factorial into n minus r minus 2 factorial divided by r plus 1 factorial into n minus r minus 1 into n minus r minus 2 factorial is equal to 2 by 3. Now there are certain things that are going to cancel. R plus 1 factorial, R plus 1 factorial is going to cancel. N minus R minus 2 factorial and N minus R minus 2 factorial are going to cancel. So ultimately you get R plus 2 by N minus R minus 1 is equal to 2 by 3. Now you cross multiply. You get 3R plus 6 is equal to 2N minus 2R minus 2. Take everything on one side. You get 3R plus 2R minus 2N plus 6 plus 2 is equal to 0. So you are getting 5R minus 2N plus 8 is equal to 0. This is your equation number 2. So equation number 1 we had got here. This is our equation number 1. And this is our equation number 2. You solve these two equations simultaneously. You get N is equal to 14 and R is equal to 4. Okay, clear? Can I proceed with the next one?
Yes, sir.
Look at the next one. Question is, prove that N minus 1 C3 plus N minus 1 C4 is greater than N C3 if N is greater than 7. Okay. So we start with this. We have N minus 1 C3. We start with this. Although we have to prove this, we'll start with this. What we'll do is we'll we'll start with this and we'll show that N is greater than 7. Okay. Greater than NC3. So now if you see this, of the expression on the left hand side is N minus 1 C4 plus N minus 1 C4 minus 1 greater than NC3, right? Now, if you remember your Pascal's rule, what is this equal to according to Pascal's rule? N minus 1 plus 1 CR, isn't it? Greater than NC3. I'm writing this NCR plus NCR minus 1 is equal to N plus 1 CR. If you see R here is 4 and N here is N minus 1. So that is why the addition of these two is equal to N minus 1 plus 1 CR, okay, by Pascal's rule. Next you get NCR is greater than NC4. This is not R, this is 4. So you get NC4 greater than NC3. That means NC4 minus NC3 is greater than 0. Now from the formula you have factorial N by factorial N minus 4 into factorial 4 minus factorial N by N minus 3 factorial into factorial 3 is greater than 0. That means you have factorial N divided by, now N minus 4 you write as it is, and 4 factorial you write as 4 into 3 factorial minus factorial N, and N minus 3 factorial you can write as N minus 3 into N minus 3 minus 1 factorial into factorial 3 is greater than 0. So you get factorial n by factorial n minus 4 into 4 into factorial 3 minus factorial n by n minus 3 into n minus 4 factorial into 3 factorial is greater than 0. That means now if you take the if you take common here first, factorial n by n minus 4 factorial you can take out, and you can also take out factorial 3. So what are you left with? You're only left with 1 by 4, right? Um, and here you are left with 1 by n minus 3, right? That means 1 by, that means not equal to 0, this is greater than 0. Now clearly if you see the product of these two, if it is greater than 0, this is obviously greater than 0, and this also has to be greater than 0. That means 1/4 minus 1 by n minus 3 must be greater than 0. Okay, so now you can uh, take the LCM, or what you can do is you can write this as 1 by 4 greater than 1 by n minus 3. Since we want to find out the value of n, you can take the LCM also, no problem. Okay, now you cross multiply n minus 3, or cross multiply in the sense that you're multiplying both sides by 4. So n minus 3 is greater than 4. You multiply both sides by 4 into n minus 3. Okay, so you're getting n is greater than 7, right? So therefore we have proved, we started from this and we proved that n is greater than 7. Okay, and move on to the next set of problem then. Number 1. In how many ways can a committee of 4 be selected out of 12 persons so that a particular person may always be taken? First part, never be taken. So before, let's write this here. A committee of 4 persons is to be selected out of 12 persons, right? And what is the condition given here? First condition is that a person is always taken. If a particular person is always taken, if that particular person, say person X, is always taken, then how many people do we have to select? Then we have to select, that person is always there, right? So that means we have to select only three persons. Out of how many persons? Out of how many persons?
Sir, 12 minus
11 persons, which can be done in 11C3 ways. Okay, 11C3 I'm not calculating, you will have your calculators to calculate. You can check this to be 165. Question number 2. A particular person is never taken. If a particular person is never taken, then what do? We have to select how many people?
4,
4 persons. Out of how many?
11,
Yes, because we remove that person from the group of 12 persons, because we don't want to select that person. Or out of 12 minus 1 equal to 11 persons. which can be done in 11C4 ways, equal to 330 ways. Okay, so this is clear.
Yes, sir.
We'll move on to the next problem then. Number 2, interesting problem. How many diagonals are there in a polygon of 8 sides to 10 sides? If you remember, I had done a formula back in your class 8 for the number of diagonals, right? Now see, if a polygon, if I have a triangle here, triangle has 3 sides, right? So how many vertices does it have? 3
3.
vertices, right? So if I give you 3 points in a plane, which are non-collinear, of course, right? How many lines can you draw?
3.
3 lines. So if I'm giving you 3 points, you are drawing 3 lines. How are you getting this? 3, because you've out of the 3 points, you are selecting 2 points, right? And drawing a line, you need 2 points to draw a line. So how many lines are you drawing?
Yes, sir.
3 lines you are drawing, right? Now suppose instead of a triangle, suppose if I have a rectangle or a quadrilateral, any quadrilateral. Uh, Let me give you 4 points, right? So how many sides can you have?
4.
4. And how are you getting these 4? How are you getting these 4? Out of the 4 points, you are selecting 2 points to draw a line, isn't it?
Yes, sir.
Right? So now also you can have 2 more lines like this, right? You can have.
Yes, sir.
So how many lines are you drawing here? How many lines? 4C2?
6.
6 lines you are
6.
drawing. But but how many diagonals are there? How many sides are there? Because there are 4 vertices, there has to be 4 sides. So therefore, what is the
Yes.
number of diagonals?
2.
If you deduct the number of sides, 6 minus 4, isn't it? The number of diagonals is 2,
Yes.
right? So which is equal to 4C2 minus 4, isn't it? So similarly, if you have a polygon of 8 sides, then how many lines are there?
8.
8 lines.
No, sir. No, sir. 8C2. Sir.
Number of lines, 8C2,
Sir, 28.
that
28.
can be drawn by taking any 2 points is equal to, because the polygon has 8 sides, you can draw 8C2 lines, right? Now, because the
Yes, sir.
polygon has 8 sides, how many vertices are there? There are 8 vertices. Uh,
Yes,
okay, it
sir.
has 8 sides. So therefore, what is the number of diagonals?
Number of diners or number of stars?
Is equal to total number of lines that you have drawn by joining all the points minus 8 sides.
Yes. Yes.
And that's your answer. You calculate this to be 20. Okay.
20.
Similarly, for the second one also, similarly, number of diagonals is equal to 10C2 because it has 10 sides minus number of sides, which is equal to 35. Okay. So this was an easy enough problem, an interesting problem also. Now, if I give you a variation of this problem, I have not given that problem, but let me just discuss this problem. If I give you, say, 5 points, okay, if I give you 5 points, and if I say that among these 5 points, how many triangles can you draw from these 5 points, given that uh, given that 3 are collinear? Let me give you 6 points, not 5. Okay, 6 points. I give you 6 points. Okay, and I ask you that how many triangles can you draw given that 3 points are collinear. Collinear means lie on the same straight line, isn't it?
Yes, yes, sir.
How can you form a triangle? You can form a triangle by joining any 3 points, right? So how
Yes,
many
sir.
triangles can you form? You can form out of 6 points,
63.
6 triangles you are
63.
forming. But
Yes, sir.
out of how many triangles are you wasting here? Minus, because three lines are collinear, these three. So how many
Sir,
triangles can you not
3C2.
form?
3C2.
3C3. 3C3. Because triangle you can form by taking 3 points, right? So one
Oh,
triangle you are wasting, right? Isn't it?
yes, sir.
And 6C3 minus 3C3. This. So this is the number of triangles that you can form. Okay.
Yes, sir.
It was just a variation of this problem. Look at number 3. I'll finish this problem. In how many ways can a committee consisting of a chairman, secretary, treasurer, and 4 ordinary members be chosen from 8 persons? Committees with different chairmen, secretaries, treasurers count as different committees. Okay, you need to choose what? You need to choose a chairman, right? A chairman can be chosen. A chairman can be chosen from 8 persons in 8C1 ways, right? Which is equal to 8 ways. Next, what do you have to select? You have to select a secretary. Now, because you have selected a chairman, a secretary. After selecting the chairman, you now have to select a secretary. A secretary can be chosen from, now because you have already chosen a chairman, how many persons you have? 8 minus 1.
7.
From 7 persons in 7C1 ways, equal to 7 ways. Next, what do you have to choose? You have to choose a treasurer. A treasurer can be chosen from 7 minus 1, equal to 6 persons in 6C1 ways, equal to 6 ways.
Yes, sir.
Also, how many ordinary members are there? 4 ordinary
5.
members. 4 ordinary members you have to choose. 4
Yes,
ordinary
sir.
members can be chosen from remaining how many persons?
5.
There are 5 persons, right? 6 minus 1 equal to 5 persons in 5C4 ways, which is equal to 5C1 ways, right? Because NCR is equal to NCN minus R, equal to 5 ways. Hence, number of ways a committee can be chosen consisting of a chairman, a secretary, a treasurer, and 4 ordinary members. Can be chosen in how many ways? 8C1
8 into 7
into 7C1 into 6C1
into
into 5C1 ways.
5C1
Okay, which is equal to 8 into 7 into 6 into 5,
into
which is
5.
equal to 1360 ways. Fine. So that
Yes,
finishes
sir.
your question number 3. So I'll stop here then.